Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today we're going to be talking about covalent bonding and molecules. This is the end of naming. You're probably happy it is. But the first thing that we talked about were ionic compounds, right? So what about covalent? So covalent compounds are attracted to one another because of their valence electrons. And nonmetals have valence electrons that can interact in a bonding way that's a little bit different than the ionic ones. Ionic ones, you either have a transfer of electrons happening. With covalent ones, you really don't. You have a sharing of electrons instead. The reason why has to do with electronegativity and a bunch of other random trends that we already talked about. But the idea is that the attraction between nonmetals is caused by a sharing of electrons, and it forms a covalent bond. Co meaning with, and then valent meaning valence electrons. So it's a sharing of valence electrons. A lot of times you'll see something like this where, oh, look at these electrons are being shared between both of the nuclei here. And so that's just kind of what makes covalent bonds work. But covalent bonds tend to form between nonmetals because most nonmetals follow the octet rule. And hydrogen follows what we call a slightly different rule. It's called the duet rule. But the idea is that if you look at the valence electrons of chlorine, there are 7 valence electrons, and then another chlorine would have 7 valence electrons. So if they actually would like to have an octet, which is 8, they can just kind of link together and share these electrons, and now both of them have 8 electrons. Hydrogen wants to have 2. So since hydrogen wants to have 2, if it hooks up with another hydrogen, now it has 2. And that's why hydrogen you always see in pairs, and chlorine is always also in pairs like this. But you don't really need to know the details of that yet. That's the next unit. So what exactly are covalent compounds? Well, covalent compounds are often called molecular compounds. And the big kind of properties that they have are really kind of found in water. Water is a molecular compound. So the first thing, they have very low melting points and they have low boiling points. Now, water doesn't exactly have a low melting point or boiling point. It's kind of the exception to the rule. But still, relatively speaking, most molecular compounds have pretty low melting points and boiling points. Another, they don't dissolve in water. Obviously, I guess we can't say water doesn't dissolve in water, but they don't dissolve in water. They also don't conduct electricity, and most people are a little bit confused. They think water conducts lots and lots of electricity. Pure water doesn't conduct a lot of electricity at all. And in fact, they tend to be liquids or gases, whereas most other things tend to be, kind of solid if we're looking at ionic compounds. Now let's look at how do you name covalent or molecular compounds. Well, thankfully you don't have to worry about crisscrossing charges or anything. Instead, we have to just look at the periodic table and kind of realize there are only really 2 types of molecular compounds. We have acids and we have molecules. Now, anytime you see hydrogen at the front of something, that's going to be an acid. There are like a couple of exceptions, one of which is like water. H2O starts with an H, but it isn't an acid. It's a molecule. But all molecules have nonmetals in them and only nonmetals in them. So if you see nonmetals, which in case you forgot are found over here, and then hydrogen also, that would mean that you are looking at a molecule. Naming acids and stuff, you don't have to worry about that until second semester. But for now, all we care about are naming molecules. So does the compound have a metal in it or ammonium? If the answer is no, it's molecular. Does it start with hydrogen? If yes, it's an acid. If not, then it's one of these instead. It's a molecule. So how do we name molecules? Molecules are named with a series of Greek and Latin prefixes. They're going to come in handy. So you just need to know your numbers from 1 to 10 and how we represent those in another language. So 1, we use mono, like you've probably heard of like carbon monoxide. That's where mono comes from, monoxide. 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So some of these should at least look familiar to you, like triangles, pentagons, and heptagons, octagons, things like that. And the rules are pretty similar to ionic ones, except we're not looking at charges, right? So the first thing you need to look at is you name the first nonmetal and then the second. But with the second one, it always has to end in "ide," just like in ionic compounds. That's why it's not carbon monooxygen, it's carbon monoxide. Everything always ends in "ide." That's why it's carbon dioxide. It has to end in "ide," even if it's a molecule. Then what you do is you add the appropriate prefix to each nonmetal. So mono can only be applied to the last nonmetal. You don't always add mono to everything. It's not, monocarbon monoxide. That's redundant. So if you say just carbon, we know that that's one thing. And sometimes with spelling, which doesn't really matter in our case, but O and A can be dropped, like, mono, tetra, penta. The little letters at the end here can be dropped if it's attached to oxide. You don't say monooxide. It's just monoxide. You don't put two O's together. It would look like monoxide or something crazy like that. So let's actually try to do this. So we have CCl4, okay? Carbon is a nonmetal. Chloride is a nonmetal. So we put them together. You get carbon because there's only one. And then we have tetrachloride. Has to end in "ide," and you have to look at what prefix that would be. So 4 chlorines or chlorides would be tetrachloride. NH3, N, that's nitrogen. H3, I have 3 hydrogens, that would be trihydride. Oxygen, and then how do we say 2? Difluoride. P4O9, so 4, that's tetra, that's phosphorus, tetraphosphorus. 9, that's nona, and then O is oxide, but nonoxide is how you kind of say that. Notice that, the spelling kind of changed. You don't put 2 O's next to each other, so it's monoxide, not nona oxide or something. And then we have CO, that's carbon, monoxide. Again, notice that only if there's a single element at the end, we add the mono prefix. How do you write formulas? You list the elements in the order they appear in the name, and then you look at those prefixes. And those prefixes, like I said, are really going to come in handy, so make sure you know your prefixes. So if I said nitrogen monoxide, what would be the formula for that? Nitrogen's N, monoxide, that's 1 oxygen, just O. Notice there's no crisscrossing, nothing fancy like ionic compounds. You just look at whatever it says. Triphosphorus, so that's how many phosphorus? Hepta, how many oxygens? P3O7, right? Tri means 3, hept means 7. Carbon dioxide, you know that from biology. CO2. Dibromine pentasulfide, di and penta, what are those? Br2, S5, penta is 5. Hexasulfur decoxide, hexa and deca, what are those? Hexa is 6, dec is 10. And that completes our flowchart. So does the compound have a metal or ammonium? If not, it's molecular. Does it start with a hydrogen? If not, it's not an acid then. Then you use these prefixes that are in Latin or Greek. All right, so hopefully that made sense. And if you have any questions, you can ask me when you see me next.